This comes out of section 7.3, derivatives of other trig functions. So this question we're asked to find the slope of the tangent line to this function y equals tan of cosecant x when sine x equals 1 over pi. It's kind of a weird thing to give us, but and then when x is in the interval 0 to pi over 2, so basically x is in the first quadrant, which makes our life easier in terms of knowing that all of our trig ratios are going to be positive. So first thing we want to do, slope of the tangent line, I think, well, I better take the derivative. So it is a chain rule derivative. The derivative of tan is secant squared, so I've got secant squared of cosecant x times the derivative of cosecant x, which is negative cotangent x times cosecant x. So kind of a big, ugly looking derivative. Now, I'm told that sine x, if sine x is 1 over pi, that means cosecant x is just pi. So that makes my life a little bit easier, because being that's reciprocal, I've got some cosecant x's there, so I've got my dy by dx is going to be secant squared of pi times negative cotangent x times pi. So that helped me quite a bit, the fact that they gave me what sine x equals. A little identity will help me with this as well. The fact that you probably recall that sine squared plus cos squared equals 1. They called that the Pythagoras identity. It's also true that 1 plus cotangent squared equals cosecant squared, and that's another one of the Pythagoras identities. And so in this case, pi squared equals 1 plus cotangent squared. So cotangent squared equals pi squared minus 1. Cotangent equals plus or minus the square root of that, but since we're in the first quadrant, I don't have to worry about the minus business, and so I've got cotangent equals that. So dy by dx, first of all, secant squared of pi. If you look at your unit circle and remind yourself where pi is, it's 180 degrees. Cosine of that is negative 1. Secant of it is also negative 1, since the reciprocal of negative 1. And when you square that, you end up with negative 1 squared, which just equals 1. And then negative the square root of pi squared minus 1 times pi. So a ridiculous slope, I suppose, but one that we can calculate anyway to say, maybe make it look a little bit better. This negative 1 squared goes away. I can say negative pi times the square root of pi squared minus 1 is the slope of our tangent line at that spot in exact value. So notice we never do need to find out what x is, some value of x, weird angle. We just need to know some of the trig ratios for it.